Hi, this is a preliminary video on the improvement to the boost converter water heater. The prior one was a very simple one. I find that people, once you show more than 5 parts, they're scared to death. But this was a video I was going to do anyway. It's a snowy, wintry day. It's nasty outside. It's about 11 o'clock. And we're putting 30 watts into the water heater. And that may not sound that much, but a water heater typically loses about 50 watt hours every hour. So this is at least preventing some loss. Again, we have the 600 watt boost converter. These are limited to about 10 amps input, so this one's good for 300 watts. If you put a second one in parallel, you could have 600 watts, which I would highly suggest if you have any kind of heating element at all that wants to power. This is a little different than the other one. What we do is we go in directly from the panels to run the boost inverter, and the boost inverter comes out to these capacitors, and it keeps them at 75 volts all the time. I had a 75N75 for a FET, and I put that in there. That's why I've limited it to 75 volts. But this boost converter stays operating all the time, and we only change the load by gating the FET on the output into the water heater. And again, the boost control circuit is pretty much the same as before. We add an extra PNP transistor and again the FET. This is the output right now. Top trace is the gate drive, and the bottom trace is the output. It stays at 75 volts. When it goes low, that's when you're providing power onto the heating element. This is being measured right off the drain. So, whereas before with the other circuit, we'd be at probably 0 watts right now, we're able to produce about 30 watts. And I probably won't get any sun for a couple weeks, so I can't fully test this, but preliminary, here's the circuit. Again, it's just the same as the TL431 circuit we had before, and what we do is drive this PNP transistor because we have to invert the signal. And there's a little pull down resistor right here going to common, and we have a teeny 4.7 ohm resistor here. This is to give a little positive feedback to the signal so it quickly transitions. I mean, you got a nice little square wave here. It's clean on the top. We're driving the gate with about 13 volts, which will put any FET into a good saturation. Right now it's on for about 1.6 milliseconds, and I think it's about 26 milliseconds total for the whole time duty. This oscillator tends to just free run, so depending upon the voltage and how much power it can produce, the frequency will change, and so will the duty cycle. But it appears to work pretty good. I've had it over 100 watts the other day when we had a teeny bit of sun. That's not a lot, but this demonstrates, basically how the thing works. And this is the circuit I really suggest you build. I haven't included all the updates to it. You can use this with a little bit of modification right with the heating thermostat of the water heater, and you can pass all the current. So when the water heater opens up, it totally removes the current from the heating element, so it's perfectly safe. But I just wanted to show you this now. Like I say, it's going to be a couple of weeks before I get down all the parts to their final values, and maybe get some sun to show you this thing really clocking away. But this is the way you should do it. The boost converter will only draw about 50 milliamps, at idle, so once it charges up the capacitor, it's not going to put a load. Right now I'm having this, it's in parallel with my charge controller. So that's the big advantage of this, is that you can use the heater controls. You can put it on any existing charge controller, whether it's PWM or MPPT, and it's very efficient, even at very low wattages. So I hope you follow this, because this is the way to do it. It's a few more parts. The last video was bait and switch, so I've got a couple people maybe interested, and this is the way to do it. So thanks for watching. Keep watching for a new video for the final form with the circuit for operating it with the water heater thermostat. So thanks again.